All right, let's take a look at question number 2. We just finished part number 1 on ellipses. On circles. Now we're going to look at another example. So how about if we had the equation in general form given by 16x squared plus 9y squared minus 32x plus 54y minus 47 equals 0. Now we're following the same instructions that we used for part 1. Let's see if we can identify what kind of conic this is. We notice that we have two variables being squared here. So that means it's either a circle, ellipse, or hyperbola. We notice that there's a plus between the squared variables, so it's either a circle or an ellipse. The squared variables have different coefficients, so that automatically tells us it is an ellipse. Okay? So this is a general form of an ellipse. All right. Now, our task, first of all, is to convert it to standard form so that we can find the properties with ease. Now, let's organize our variables. 16x squared minus 32x. The x's together, plus 9y squared plus 54y. The y's together, and then you subtract 47 from both sides. Okay, what we're going to proceed to do now is split our variables into their respective worlds, the x world and the y world. Okay, now let's see here. When we are completing the square, we want to make sure that the squared variables do not have a coefficient. So our goal, first of all, to create two perfect square trinomials is to factor out the coefficient of the squared variable from the two terms in their worlds. Okay, so I'm going to factor out 16 from these two terms. So I'm going to have 16 times x squared. If you factor out 16 from negative 32, you'll be left with negative 2x. And then we're going to add a term that completes the square in the x world. Okay? Plus, the same story here, to have a to put this in a form that's easy to complete the square, we have to factor out the coefficient of the y squared, which is 9. So we factor out 9 from these two quantities in the y world. We'll have y squared plus 54. I'm sorry. If we factor out 9 from 54, we'll have 6 plus 6y. And then we're going to add a term that completes the square in the y world. Okay, so plus that term that completes the square equals 47. Now what are we going to add on the right side to make sure that we have a balanced equation? Well, before we do that, let's find out the terms that I'm going to insert here first. Okay, so in the x world, let's see, v of x is negative 2. So to make this a perfect square trinomial, we'll divide that by 2, negative 1, and you square that, equals 1. Okay, so we add a 1 here. And then in the y world, what we'll do is we'll extract our b of y, which is 6, divided by 2. That yields 3. And when you square 3, you get 9. Okay, so put a 9 here. Okay, so what do we add on the right side to preserve equality in our equation? We're going to add, you don't just add the number, you have to multiply it by the number you factored out. Okay, so we're going to have plus 16 times 1 that I inserted in the parentheses, plus, you have a 9 here, 9 times the 9 in here. Okay, so this is slightly different from the circle case. When we're doing the circle in the previous problem, we didn't have a coefficient outside the parentheses, so this term was sufficient to be added in the right side to preserve equality. But anytime you have a number outside, you must multiply by the number you introduced. All right, so let's simplify this further. We're going to have 16, and then let's factor this using the factoring trick we went over before. You root the first and the last term, and then you bring down the middle sign, and then you'll have x minus 1 quantity squared plus 9. You read the first and the last, and bring down the middle sign, and you have y plus 3 quantity square equals 47 plus 16 plus 81 is 144. Now to place our ellipse in standard form, we have to set this equal to 0 and also address these constants in front of the squared quantities. They shouldn't be there. Okay, so let's deal with this side first. We divide the entire equation by 144, 144, 144, and 144. Okay, now let's reduce that. We're going to have 16 goes into itself once and goes into 144 9 times. So that yields x minus 1. Let's try that again. Over here 9 times. So we have x minus 1 quantity square over 9 plus, then 9 goes here 1, 9 goes into 144 16 times. So for the y world, we have y plus 3 quantity square over 16 equals 1. This is excellent because by dividing by 144, we also got rid of the coefficients in front of the parentheses. So now we have the standard form. Standard form. Okay, now we're ready to find the properties. Let's write that down, properties. Okay, first thing we have to do is identify the conic. We already did that. This conic section that we are dealing with here is an ellipse. Okay, so the conic is an ellipse. Next thing we have to identify is the center. The center is HK. So we have the opposite of this number is 1. Opposite of that, negative 3. So there goes your center. And the next thing is the direction of axis. Direction of axis. Now, you know that the x-axis goes side to side. That impacts the direction of this number here. And then the y-axis goes up and down, right? Okay, so let's start with the x piece. The square root of 9 is 3. So we're going to go 3 units side to side from the center. Square root of 16 is 4, so we're going to go 4 units up and down from the center. Alright, so we have to identify the major and minor axis, since the major axis determines the orientation or direction of the C for the foci. The major axis is the bigger of the two. We can clearly see that the y direction is a major. Okay, so this is a major axis direction. And this is the minor axis direction. All right. Okay, now next thing we need to find is the C of the foci. C of the foci. There are two focus here. C of the foci is the square root of, we have a plus here, so we're going to do the difference in the denominator, 16 minus 4, which is equal to 16 minus 4 is 7, so square root of 7. And if we plug that in our calculators, that's approximately 2.65. What direction does this go? It goes in the direction of the major axis, up and down. Okay? And then the eccentricity of our ellipse, how stretched it is in the direction of the foci, of the major axis, sorry, is simply C divided by our major axis. Okay, so C is square root of 7, and then we just divide that by 4, and that will give us the length of our, that gives us the eccentricity of our ellipse. So if you plug it in your calculator, this is approximately 0.66. All right, now let's take a look at the graph of our ellipse. So let's see, we're going 1 to the right and 3 units down, so our ellipse will be centered in quadrant number 4. So let's set up our coordinate system, keeping in mind the location of the center. Alright, so I'm shifting my x-axis upwards considerably here because my center is in the fourth quadrant. Okay, so now there goes my x and my y-axis. Let's label it y and x. Alright, now we're going to graph and fully label our ellipse. First thing we're going to graph is the center. 1, negative 3, 1, 1, 2, 3. There goes the center. We're going to go 4 units up and down. 1, 2, 3, 4 for the major axis. 1, 2, 3, 4. And then 3 units side to side. 1, 2, 3. And then 1, 2, 3. Okay? And then we can draw our ellipse as best as we can. Just connect the dots, kind of like an oval shape. That's not good. Let's try that again. Strip this part. Alright, so there goes your ellipse. Now let's go ahead and start labeling our ellipse. So I like to focus my attention on the major axis first because that's where a lot of the action is. Okay, so this line, this segment right here is a major axis because it's the longer of the two. So let's start labeling. We're going to start with the center. Just right there is the center. The center is 1, negative 3. Next thing we're going to graph are the full side. 2.65 in both directions. So I'm going to go up 1, 2.6. That's somewhere here. Alright, and then 1, 2.6 is somewhere here. Let's label those. This is, we'll call this focus 1. Focus 1. Coordinates. You just simply add 2.65 to the y-axis since we're going in the upward direction. So we're going to have 1, comma, 0.35. I'm sorry, negative. Fix that. 1, comma, negative 0.35. All right, and then going down 1, 2, and then 0.65 gives you focus 2. Let's label that focus 2. It's going to be 1, comma, subtract 2.65. Here you have negative 5.65. Okay. All right. Now let's shift our attention to the vertices. The vertices on our major axis are our major vertices. Okay. So let's label this. This is major vertex 1, major vertex 1, and the coordinates are going to be 1, comma 1. Okay, and then this right here is major vertex 2. Major vertex 2 is going to be let's see, we're negative 3, 4, 5, 6, 7. So 1, comma, negative 7. Major vertex 2. Now next thing we're going to graph is our major axis line. Let's go ahead and graph that. Our major axis line, let's make it red. So our major axis line is this line right here. So let's go ahead and label it. So this is our major axis line. Major axis line. And it has the equation x equals the x coordinate of the center, which is 1. Alright. We also have to label our major axis. This right here is our major axis. And also how long it is. Okay, so this is our major axis. Major axis. And it's well, let me put it on the other side because I'm running out of space. So put it over here. Major axis length is 4 units up and down, total of 8 units. Okay, so that's how long our major axis is. Now let's shift our attention to the minor axis. There isn't too much going on there. We're just going to label our we're just going to label our minor vertices, and that will, and also the length of our minor axis, and that will be that. Okay. So this is minor vertex 1, minor vertex 1, and the coordinates are, let's see, 1, 2, 3, 4, 1, 2, 3, 4 comma negative 3, or you can simply subtract 3 from your x coordinate of the center, and then that takes you right here. Okay. Now let's shift our attention to the other, to our other vertex, minor vertex 2. So this is minor vertex 2, and the coordinates are, starting from 1, negative 3, we're just going to go 1, 2, 3 here. So the coordinates are 1, 2, negative 2, 1, 2, 3, negative 2, comma, negative 3. So negative 2, negative 3. And last but not the least, let's graph our minor axis line. Okay, the line containing our minor axis. Let's make that blue. So we're going to have the minor axis line, and then we just indicate the equation of our minor axis line, and then we'll be able to move on to stating the meaning. Okay. All right. So there goes our minor axis line. Minor axis line, and the equation is the y coordinate of your center, which is negative 3. So y equals negative 3. So there goes your graph in fully labeled ellipse. Okay, so let's go ahead and state the meaning or the definition of an ellipse in the context of this problem. Go ahead and write it down. So let's have everything in view. So the definition in the context of this problem is as follows. The locus of points whose distance, or whose sum of distance whose sum of distance from two fixed points, these fixed points are the foci. Okay, so let's label them foci 1, focus 1, fixed points. Is that a view 1, comma, negative 3, negative points 3, 5, and the second focus is 1, comma, negative 5.65. So whose sum of distance from two fixed points is constantly the length of the major axis is constantly 8, is the ellipse with the equation 16x squared plus 9y squared minus 32x plus 54y minus 47 equals 0. Or you can place the standard equation. They mean exactly the same thing, all right? So that's that.